All right, word problem day with systems. We're going to go back to the last day's notes. There was a word problem at the bottom. I just figured we would do all the word problems together. So, theater group sold a total of 440 tickets for $3,940. There's your first equation. You just have to read what kind of tickets they are. So you have the regular tickets, which are $5. Premium tickets are $15, and elite are $25. So, you know you're going to have regular tickets plus premium tickets plus elite tickets, and you sold 440 total tickets. But then each regular was $5, each premium was $15, and each elite was $25. And you made a total of $3,940. And we got to get one more equation. So we found that the number of regular tickets is 3 times the number of premium and elite tickets combined. So regular is equal to 3 times the sum of the premium and the elite tickets, which we could just say is 3P plus 3E. Okay, so we have our system here with 3 variables. Now, since we have R already by itself, here's a little trick that you can use. We could say that 3P plus 3E plus P plus E equals 440. All I did was substitute this into R. And we can do it again and substitute it into that R. So we can have 5 times 3P plus 3E plus 15P plus 25E, which is equal to 3,940. And what happens when we do that is this can be simplified to 4P plus 4E is equal to 440. And this guy will turn into 30P plus 40E is equal to 3,940. Okay? And by doing that, look what you're at. You're back to a 2-variable system. It's a different way of solving. So if you were to just substitute or multiply this top one by a -10, you're going to end up getting your e's to cancel. And we're just going to save a little bit of time and just assume that you know how to solve from here. Once e's cancel, you're going to get P. And P will end up being 46. And then you're going to substitute that back in to find out that E is 64. And now that you know both of those, we just have to add those together. You get 110, and the regular is 3 times the sum of P and E. So that means your regular is 110 times 3, so we have 330. So your final answer is 330 regular tickets, 46 premium, and 64 elite tickets. And you are done. So that was the problem from yesterday's notes with 3 variables. What we're going to do is we're going to continue this lesson with the day 5 notes, and we're going to do some big word problems right now. So this one is Luke and Bud go paddle boating on the Des Plaines River. They check out a boat and head out along the river for a while, and then they turn around and come back to the boat dock. So we have 2 things. We're going to have T be the number of minutes, but F of T is going to be the number of meters that they are from the boat dock on the way out. So they leave the dock, and this equation, F of T, is going to be their way out. But then coming back in, they're going to have a new equation, which is -17T plus 510 once you read part B, because obviously the current of the river is going to be a little bit different on the way out and the way coming back in. So part A says the equation for F of T on the way out is 32T. So we could just, for fun, call this D is equal to 32T. Okay, just an easier way for you to look at this problem. Okay, and we're going to find F of 3 and we're going to find F of 10. So to find F of 3, it's just 32 times 3, which we know is 96. And F of 10 is going to be 32 times 10, which is 320. And of course, these are both in meters. Equation B, we're told, is negative 17t plus 510. Now, another way to look at that is the same as before. The distance from the dock is negative 17t plus 510. So, if we're going to find G of 18, that's going to be 204 meters. And if we find G of 23, that's going to give us 119 meters. Okay, so as you can see, as time gets bigger for the first equation, you get further away. But then as time gets bigger for the second equation, we start getting closer. Because remember, the second equation, we're getting closer to the dock. We're on our way back. Okay, so part C says that we are going to sketch. Remember, when I say sketch, it doesn't have to be perfect, but you better give me some good points. We're going to have to sketch this graph, and we're going to give some dotted lines where the graph does not really apply to this equation. So what I'd like you to do is I'd like you to pause for a minute and see if you can do a nice little sketch of this on your own, and then you can check it with mine. Okay? So okay, here's a word problem where Luke and Bud are going to go paddle boating down the Des Plaines River. And they're going to check out a boat, and then they're going to return to the boat dock. And what we're going to do is we're going to have two equations. We're going to have an equation that represents their way away from the boat dock, and then we're going to have an equation that represents their way back to the boat dock. Because, you know, obviously you have upstream and downstream. We're going to find out that these are going to be a little bit different for times. So that's why we need two different equations. So so away from the boat dock, or we could also just simplify it and say D is equal to 32t. F of t, so the distance away from the boat dock as time increases on your way downstream, or is it upstream? We'll find out in a second. We're going to find F of 3 by just substituting it into 32 times t, and that's going to give us 96 meters. If we find F of 10, we're going to find out that that is 320 meters. And that's simply substituting a value into the equation 32t. As you can see, they're getting bigger as time goes on, but we're going to end up coming closer because we're going to find out that G of t represents the distance as we are coming back in. So if we substitute and find F of 18 into our equation negative 17t plus 510, then we're going to end up with 204. So as you can see, 18 is bigger than 10, so as time elapses, we're starting to get closer. Okay, so obviously you can kind of predict that we are about to eventually find out when they're equal. So this one, we find G of 23, we're even closer to the dock. We're down to 119 meters. Okay, and this could also be thought of as the distance from the dock is negative 17t plus 510. Okay, so part C says we've got to sketch the graph of F and G on the same axes. And then we're going to use dotted lines to represent parts where the domain does not apply. Okay, so it might actually help to look at these equations here. What I'd like you to do is pause and try to sketch this graph. Okay, now think about it. You're going to want to check with mine before you move on. But like I said, it's good practice to come up with good sketches of graphs. I say they don't have to be perfect, but they have to be easy enough for me to understand. So pause and try it. Does your equation look a little bit like mine graphed out on this little sketch? What I did is I just kind of figured about going in 5-minute increments, and I'm going up by 50 along your y-axis to give us the distance from the dock. So the first equation is right here. This is our 32t. And what I kind of did is I just went up by 32 approximately. And this one, we started by going down 17, but we actually shouldn't be at 35. That's my mistake. We actually should be back by 30. So what I did there is I just kind of predicted what the y-intercept of 510 was, and I just started coming down. And we know they're eventually going to intersect, okay? So the reason we have some that are dashed is because, remember, they go out in their little boat, and then eventually they decide to turn around. So that's why we have dashed lines. They don't start 510 feet away. They actually start at the dock, and then they go out, and then they turn around, and then they come back. But this is a graph that is relevant to time, so that's why it's going to continue to go further out. So there's a little sketch. So we're going to calculate at what point the graphs intersect. Remember, this is like distance. So all you have to do for part D is just set the two equations equal to each other. So we could just say 32t is equal to negative 17t plus 510. Add the 17 to this side, and we're going to have 49t is equal to 510. And we're going to find out that the time t is approximately 10.408. And if we were to substitute that back in, we would find out that the distance is approximately 333 meters away. Okay, so that's the point where the graphs intersect. They intersect at 10.408, 333. And that tells us how far. So in the real world, what is happening in part D? So that's saying that after 10 minutes, so after 10 minutes and some change, they turn around 333 meters from the dock. They're starting to come back. Okay, so when did they arrive back at the boat dock? Well, that's when I said you should estimate with the equation. So we're 510 feet away, coming back at 17 meters per minute, and that's going to just solve for t, and we're going to get t is equal to 30. That's how I knew what this point was here before I accidentally plotted it on 35. So we're going to, assuming they were going the same speed through the water for both parts of the trip, that they start out by going upstream or downstream. Justify your answer. Well, what we can do is we can use the time to figure out, well, we know that on their way out, it only took them 10 minutes and some change to get out there. But on the way back, we could figure out how long it took them to get back. If the entire trip was 30 minutes, then all we have to do is subtract 10.408 from 30, and that's going to give us, on our way back in, that's 19 minutes, 0.592. So we could say that on the way out, they were going downstream, because they got there a lot faster. If you're trying to row against the current, it's going to take you a long way, or a long time. So we're going to try to figure out the speed of the current. So remember, we know that D is equal to rate times time. So on our way out, D is equal to the rate of the river plus the current times t. And on our way back in, we're going to be traveling, we're going to be rowing, and we're going to subtract the current times t, because we're paddling against the current. Okay, so this is going to give us rowing plus the current times our time it took, 10.408. And on our way back in, we're going to be rowing against the current, and that took us 19.6 approximately. And we're just going to solve those two equations because they are both equal to the distance of 333. Okay, and then that's just going to take a little bit of solving systems to figure this out. And as you can see, the currents are going to be eventually canceling once you multiply and solve algebraically. And we're going to find out that we have a rowing speed of 24.505, which means the current is going to end up being 7.514 meters per minute. Okay, that's the current, because we found the rowing speed. Okay, so that was a pretty big word problem, and that's just the type of example of problems you will see in this class. We are going to need a part 2 to this video because there are still 2 more word problems to talk about. So that's it for this one. Be ready to watch part 2 next. Thank you. Have a good one.